Alright, this is a recap on writing proofs. Today was October 18th. October 18th. When you're writing proofs, we have a couple facts we're going to have to really worry about. We're going to be really sort of focused on two-column proofs. That's going to be the most common kind of proof you see. Your proofs will always involve a couple clear steps of listing given information. The information you're given will always be provided. You cannot do a proof without having that information ahead of time. Draw a diagram if needed. It always helps to draw a picture. Always helps. We're going to be making some arguments about the steps we're taking along the way. We're going to be listing the reasons why we're making those arguments or those statements. And at the very end, we'll be stating what we were setting out to prove. We're going to be connecting each statement, each idea that we write, with a reason behind it. So in class today, we started off, a lot of your proofs, when you're doing them online, will be two-column proofs. They'll often be fill in the blank or drop-down menus online. So we started off in class today on identifying whether a given value or given word or sentence was a statement or a reason. Your statements are facts specific to your problem. Reasons are things like definitions, postulates, theorems, or properties. So for some of our classes today, we went ahead and identified whether something was a statement or a reason. Remember, statements are facts very specific to the problem. Each statement is specific. A reason is generally general. R is the midpoint of UV. That's a statement. We're going to put a letter S next to it for statement. S is going to be statement. R was reason. We did this just to identify things. UR equals RV. That's pretty specific. That's a statement as well. Given. That's a pretty general thing. It's not talking about anything in this problem visually, so it's going to be a reason. Given is the most common thing you'll see in a proof to begin with, because you need to have something to begin with. We start with the given information. We're going to have to start our problem with given information. R is the midpoint of ST. That's pretty specific. That's another statement. Definition of midpoint. That's going to be a reason for us. It's a definition. Again, your definitions are generally a reason. Your postulates are reasons. Theorems are reasons. Then we had reasons the rest of the way. We were asked to complete this two-column proof. We were given these facts. SR is equal to RT, SR is also equal to UR, and RT is equal to RV. And we wanted to prove two separate facts. It's not common, but we were asked in this case. We wanted to prove R is the midpoint of ST, and that R is the midpoint of UV. You've got two things we're proving. And we have three given statements. As a reminder, starting off your proof, you always start with given. For a proof, start with a given. We see SR equals RT. Where are we getting that statement from? Well, it's given to us. So we went ahead and wrote given. It'd be a decent idea, since we have SR equals RT, to mark that inner picture. We'll mark that inner picture. SR is the same length as RT, and we do that with the tick marks. Now, some of you are really good at identifying what the next step is. We only know about these 3 points so far in our statements, so I can't necessarily talk about UV. I can't talk about UV or RV. We want another statement here. We're used a given. The most logical thing to go with is R is going to be the midpoint of ST. That seems like the most reasonable statement next, because we've got SR and RT. We see SR and RT. R is clearly in the middle between S and T. So R is the midpoint of ST. We decided on this one instead of the R as the midpoint of UV because, again, we don't know anything about U or V currently in our proof. If we had mentioned UR or RV in our proof, so far we could have actually talked about it, but right now we just had SR and RT, so we could only talk about those 3 points. Since you have a word bank, it's always a good idea to cross off what you've used. Statements will only ever be used once. A reason could be listed multiple times. You might use a reason more than once, but a statement you never really need to use more than once. Third line, we have SR equals UR and RT equals RV. Where are we getting that? Well, again, they're given to us. We'll always generally start with a given statement, but it doesn't mean all the given statements have to be done first. Let's take a quick note that R is the midpoint of ST. That was one of the things we wanted to prove, and we've proven it in that second line. This first statement here that we wanted to prove, we've done so. So we just still have one more thing to prove. Now, as a good test-taking strategy, if you know you want to prove something, we want to prove R is the midpoint of UV, the thing you're trying to prove is always the last thing. That's our step 4. State what it is you have proven. We're trying to prove R is the midpoint of UV, so the last thing we should prove is the thing we want. Proof, we start with a given. And end with the goal. We want this. We know it's going to be the last thing. We'll write that down. We know that the last thing should be R is the midpoint of UV. Since in our case there's only one other statement to have, process of elimination tells us UR equals RV has to be our fourth line here. We are going to make sure we understand how we're getting this line. It's important that you're able to understand how we get this line. We're currently just saying substitution. but it's not always easy to see. We'll emphasize that in a second. What I would recommend we do is, if we want to see how we get line 4 here, let's look at the 3 previous given statements. Let's start off with one we know. Take a look at the first line. SR is the same as RT, right? We wanted UR to be on the left-hand side. Is there something that relates SR to UR? Yeah, our statement here. So that's what we did. We replaced SR with UR, and that's why we've got SR on the... SR was replaced with UR. We wanted to replace RT with RV. We see that happens. If the RT on the right-hand side is replaced by RV, we get RV on the right-hand side. UR equals RV is just coming from this first given statement, having the left side replaced by UR and the right side replaced by RV. We substituted. Something you might see occasionally instead of substitution, you might see transitive property at times. They're pretty interchangeable. They're not exactly the same, but they're pretty interchangeable. Last thing, we want to go from UR equals RV. Let's mark that under picture. UR and RV are the same lengths. We want to be able to say that R is the midpoint of UV. Well, R is in the middle between UR and RV, so we can do that. That's just the definition of midpoint. Your definitions generally work in 2 directions. Definitions are usually biconditional. Meaning, so far we've seen UR equals RV. We're able to say that R is the midpoint of UV. We could go the other way. R is the midpoint of UV, so UR is equal to RV. We get to go back and forth between these 2 ideas, between lines 4 and 5, using the definition of midpoint. It's something you occasionally have to worry about. We'll see more of these. This is not the end of it here. There was one other example, but I'm going to record it in a separate video. We did example 1 here. We've got a sort of a check that we did together on the back. That'll be the next video.